Hello students, now let us solve the problem related to the atomic structure. The question is given in the spectrum of the hydrogen, the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series is. Here four options are given. So this question is appeared in NEET 2013. We have to calculate the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series. So before going to calculate, let us recall how the Lyman series arises. See, the Lyman series arises only when an electron in the hydrogen atom makes transition from n is equal to 2 or greater than 2 to the lowest energy state or the ground energy state, that is n is equal to 1. So either it may be from n is equal to 2 or make transition from 2 to 1 or maybe from 3 to 1, 4 to 1. So here for the longest wavelength in the Lyman series, the longest wavelength means very short energy drop. Very short energy drop means it must be makes transition from the n is equal to 2 to n is equal to 1. So using the Rydberg formula, that is 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So here n1 is for the longest wavelength in the Lyman series, means very short energy drop, that is when transition makes from n is equal to 2 to 1. So n1 is here 1 and n2 is 2. Now substitute the values, that is 1 by lambda is equal to r into 1 by 1 square, that is 1, minus 1 by 2 square. So r into 1 minus 1 by 4, that is r into 4. Here 4 minus 1, that is 3. So 1 by lambda is equal to 3r by 4, or here we have to calculate the wavelength, that is lambda is equal to 4 by 3r. So this is for the longest wavelength in the Lyman series. We have to calculate the ratio between the Lyman series to the Balmer series. So now let us calculate the longest wavelength for the Balmer series. Here again, the Balmer series arises when an electron of the hydrogen atom makes transition from n is greater than or equal to third level to the second level of the energy level. So either it may be from the third level or maybe from the fourth level, fifth level to the second level. So here again the longest wavelength in the Balmer series means very short energy drop. So this happens only when the electron of the hydrogen atom makes transition from the third level to the second level. So here n1 is 2 and n2 is 3. Again using the same formula, 1 by lambda is equal to r into, substitute the value for the n1, that is 2 square minus 1 by 3 square. So r into 1 by 4 minus 1 by 9. Take the LCM, that is 36. 36, 9 minus 4. Here 9 minus 4 is 5. 5r by 36. So lambda is equal to 36 by 5r. This is for the Balmer series. So now to calculate the ratio between these two, that is lambda of the Lyman series to the lambda of the Balmer series, that is for the longest wavelength. Here 4 by 3r divided by 36 by 5r, that is 4 by 3r. This is go to numerator and this will remains in the denominator. So that is 5r by 36. Here r get cancels and here 4 1s are 4 9s are. So 9 3s are 27. In the numerator it is 9 27 and in the denominator it is 27 and in the numerator it is 5. So the answer, the ratio of the longest wavelength in the Lyman series to the longest wavelength in the Balmer series is 5/27, which is the third option. Thank you.